Alright, we're going to take a look at an example problem, and we're going to take a look at number 6 on your at-home practice. So it says that two objects collide in a head-on collision. Before the collision, the first object, which has a mass, so the mass of object 1 is 394 kilograms, was traveling at a velocity of 10.3 meters per second east, while the second object, mass 2, 873 kilograms, was traveling at a velocity of 6.2 meters per second west. So that's a negative 6.2, right? Because it's in the westerly direction. After the collision, the first object stops completely. So this is all of the before information. After the collision, again, the masses are staying the same because they're not sticking together. So the mass of the 1 is still 394. The first object stops completely, so velocity of the first object after the collision becomes 0. What is the velocity of the second object after the collision? So the mass of the 2 is going to stay the same, obviously, so that's 873 again. And then lost my train of thought. After the collision, the first object, well, what's the velocity of the second object? So it's asking for the second object's velocity after the collision. So that becomes our x. Okay, so remember we have to split our data into befores and afters. So our first step is going to be calculate the momentum of each object before the collision. So let's take a look at our first object. Our equation is P equals mv. So our first object is going to have a momentum of 394 times 10.3, and that's a positive 10.3 because it's going east. So we have 394 times 10.3. On our calculator, we get 4,058.2 kilogram meters per second. Second object before the collision, P equals mv. P is equal to the mass, which is second mass, which is 873, times a negative 6.2 meters per second. So we get 873 times negative 6.2, and we get a momentum of negative 5412.6 kilogram meters per second. So this is the first momentum over here. This is the second momentum over here. So remember, in a closed system, momentum before is equal to momentum after. So we can take the momentum of the first object plus the momentum of the second object, and that's equal to the momentum of the first object plus the momentum of the second object after the collision. So let's start plugging and chugging here. We have P1, which is 4058.2. Then we have P2, which is negative 5412.6, and that's equal to P1 prime. So that means mass times velocity 1 prime, which is after. So we put the prime here. See how I put the little hash mark up here? It's just to tell you that that's the after portion of the collision. So we have 394, so we have to do mass times velocity here. So that's equal to m1 v1 prime plus m2 v2 prime. So we can combine this guy real fast. 4058.2 minus 5412.6. And we get negative 1354.4, and that's equal to mass of the first one after the collision, which is still going to be 394, times the velocity of the first one, and you guys remember that it comes to a stop, so that's going to be times it by 0, plus the mass of the second one, which is 873, times the velocity of the second one, and that's what we're trying to solve for, so that becomes 873x. So now looking at this equation, 394 times 0 gives us a 0. That can go away. So we have negative 1354.4 is equal to 873x. Divide both sides by 873. And we get negative 1.55 meters per second. So the negative tells us that it's moving west. So it's 1.55 meters per second west, or negative 1.55 meters per second east. So in our answer choices, we get negative 1.6 meters per second east. Answer is letter choice A.